We know that when we make measurements, there are various types of errors. Errors can be expressed in different ways. It can be absolute error, or mean absolute error, or a relative error, percentage error. So let us see what is error analysis. If a physical quantity A is measured n times, we will get different values. First time when we measure it is A1, second time if you measure value is A2. So you'll get n observations. Add all the observations and divide by the number of observations. So you will get the mean value. Then from the mean value you subtract the first value. So you will get that difference. That is delta A1, difference between the mean value and the first measured value. Similarly, you subtract second measured value from the mean value. So that is delta A2. Then similarly, you subtract all the measured value from the mean value. You will get the difference. So this is what is known as absolute error. Delta A1, delta A2, this is called absolute error. Mean absolute error. Delta A1, delta A2, delta A3, they are absolute errors. So it can be positive or negative. You take the modulus of delta A1, delta A2 and add and divide by the number of observations. So you will get a mean absolute error. Mean absolute error is the arithmetic mean of the magnitude of the absolute error. You are adding all the absolute error after taking the modulus and then dividing by n. So that is a mean absolute error. Next, relative error. Mean absolute error you divide by the mean value, delta AM divided by AM. That is relative error. Then percentage error. Relative error you multiply by 100. So you will get percentage error. Now let us see in an example. Period of oscillation of a simple pendulum is measured and there are 5 observations. First we have to get a mean value. So add all the values and divide by the number of observations. So you'll get the mean value. Mean value is 2.624. Then round it off to 2 digits after the decimal point, because in the given data there are only 2 digits after the decimal point. So in the answer also there should be 2 digits after the decimal point. Next, absolute error delta T is Tm minus T. Tm is the mean value. Then from the mean value you subtract the value of each observation. So this mean value is 2.62. You subtract the first value. Then similarly you subtract all the other values from the mean value. So here some of the values are positive, some of the values are negative. Some of the values you can see negative, some of the values positive. After taking the modulus or magnitude, you add and divide by the number of observation. That is mean absolute error. This is minus 0.01. So when you take the magnitude, it is 0.01. Then add all these absolute errors after finding the modulus. So mean absolute error is sigma magnitude of delta Ti divided by number of observations. So you will get the value as 0.11 second. Then relative error delta Tm divided by Tm. That is mean absolute error you divide by the mean value. Mean absolute error is 0.11, mean value is 2.62. So you will get this value 0.04. Then percentage error, relative error is to be multiplied by 100, so it will be 4%. I hope you have understood what is the absolute error, mean absolute error, relative error and percentage error. Thank you for watching.